7a, one reason often suggested for global warming is the enhanced greenhouse effect. Now, this idea of enhanced greenhouse effect usually has to do with human activity. So when we talk about the enhanced greenhouse effect, what are we meaning? Well, we're basically saying that there is more energy that has been trapped within the surface due to the greenhouse gases such as carbon dioxide and water vapor, but mainly carbon dioxide. So we have more greenhouse gases absorbing and re-radiating infrared radiation. So it's absorbing the infrared radiation and then re-radiating that infrared radiation back into the Earth system. So back into the Earth system. State two other possible causes of global warming. So these would be non-human causes. So this would be an increase in the amount of energy, that we receive from the sun. In forms of greater solar activity, solar flares and so forth. We could have volcanic activity that could increase the amount of CO2 gas in the air. That can also be a possible reason. B. One effect of global warming is to melt the Arctic ice sheet. The following data are available for the Antarctic ice sheet and the Earth's ocean. So we get given here the area of the ice sheet, the average thickness of the ice sheet, the density of ice, the density of water, and the area of the Earth's oceans. But what you've got to be careful with here, notice that you've got here kilometers squared, you've got meters, and you've got meters cubed. So you're going to need to do some conversions from kilometers into meters. And we know when you do that, we have to times by 1,000. If I go from kilometers squared to meters squared, I've got to times by 1,000 times 1,000. So it's times by 10 to the 6 would be my conversion for that. So using the data, determine the mass of the Antarctic ice. Now, we have here the density of the ice, and we have the average thickness of the ice, and we have the area of the ice sheet. So using my formula that density is equal to mass over volume, I'll have mass is equal to my density times my volume. So I'm going to get my mass is equal to my density of the ice is 920 kilograms per meter. So we're going to have our volume in terms of meters cubed. So I'm going to multiply that. Now my volume is obviously going to be my area times by my height. Whenever we view this as the idea of a prism. So this is perhaps your sheet, and you've got your height like this height, this area, the cross-sectional area times by the height. The area times by the height gives you your volume. So we have got our surface area. It is, we are told that is 1.4 times 10 to the 7 kilometers squared, but I must put that in meters squared. So to do that, I need to do that over there. So I'm going to have to multiply that by 10 to the 6. And then I'm going to have that times by my thickness, which is 1.5 times 10 to the 3. And when I multiply that all out, I get something like 1.9 times 10 to the 19 kilograms. So that's the mass of the Antarctic ice sheet. Then it says we also want to determine the change in the mean sea level if all the Antarctic ice sheet were to melt and flow into the oceans. So what would be the volume of this in water? Now we know from our formula, from this formula over here, that volume is equal to my mass divided by my density. But now we're talking about water. So we've got this mass is 1.9 times 10 to the 19, and my density of the water is 1,000. So I'm going to have to divide that by 1,000, and I'm going to get my volume, my new volume, is going to actually equal to 1.9 times 10 to the 16 meters cubed. So now that's all flows into the sea, and we have the area of the ocean is given by that. So the area times by the height will equal my volume, and therefore we will have the height is equal to the volume, 1.9 times 10 to the 16 meters cubed, divided by my area. Now that's over here, that's 3.8 times 10 to the 8, but that's kilometers squared, so I must multiply that by 10 to the 6 to make it into meters squared. This is meters cubed, meters squared. Obviously that's going to cancel out that, and we're just going to be left with meters, which is the height, and this works out to be 50 meters. And then the final question here for C, outline the difference, if any, that the melting of the oceanic ice sheets makes to the mean sea level of the Earth. Well, in the oceanic ice sheets, the ice is actually displacing the water. So your ice actually displaces the water, the H2O. Most of the ice is actually underneath the surface. 9/10 is underneath the surface, and as you can see, your density is about 9/10. So in actual fact, because the density of ice is less than water, it floats. So about 9/10 is underneath the water, and therefore when that ice melts, it will have a minimal effect on the level of the sea levels, or no effect.